Assalamualaikum and good evening to Doctor. So we from group 4, which is this is our group segment. This is our members, which is we have Amir, Haris, Muhammad Iman, which is me, Wan Nur Hajar, Laila Suhaila and Arisha Nabila. So for the introduction is this project aims to analyze two distinct but relevant questions related to student performance behavior using real-world educational data. Both topics focus on group comparisons using non-parametric statistical tests in IBM SPSS to ensure accuracy even when data does not meet normality assumption. Next, I will pass to another person for topic 1.
Okay, so untuk topik 1, kita orang dapat do online and face-to-face student perform equally on exam scores. So, apa yang kita nak tengok kat sini, macam mana online dengan face-to-face boleh mempengaruhi student punya performance, especially on exam scores. Next. So, for problem statement, macam kita tahu lepas COVID-19, student ada dua learning method, which is face-to-face and online. So daripada situ kita conduct analysis untuk tengok sama ada student different learning method affected by CGPA or not. The next. So this is for data set. The data set actually collected from data.mendeley.com. Data.mendeley.com ni dia macam satu site helping student ataupun academician untuk buat research ataupun helping diorang punya education lah. And then data ni is a real world data set. Data ni pula dia publish tahun 17 September tahun 2024, consist of 31 features. So data ni actually dia collect information untuk measure student performance daripada private institution in Bangladesh, student daripada computer science and engineering department student. Next. So for data cleaning, first one, kita orang masukkan data cleaning ni dengan gunakan Python. So first one, kita kena filter out dulu unrelated features. Macam kita tahu kita nak buat learning mode dengan CGPA, which is kita perlukan dua sahaja features. Jadi daripada 31 features tu, kita filter out mana yang tak penting. So instead daripada kita drop satu-satu features, kita just extract the features yang penting, which is learning mode and CGPA. So untuk number 2 ialah identify null values. So daripada kat sini, kita nampak kita buat coding untuk identify null values. So actually null values tu tak ada. Kita boleh kata yang data ni quite clean. Tapi dia bukan totally clean sebab kita ada juga data tu walaupun dia bukan null value tapi dia punya value is 0. So kita conduct step number 3 lah, which is kita kena filter out the outlier. So filter out outlier ni kita orang letakkan threshold, CGPA bawah 2 kita orang akan filter out the CGPA less than 0 lah. Sebab bila CGPA less than 0, saya tak anggap benda tu disebabkan online ataupun face to face learning method. Saya anggap benda tu macam ada factors sebab bawah daripada 2 tu macam terlalu teruk lah. Lepas tu after conduct filter outlier, kita nampak yang CGPA bawah 2 dah filter out dalam 49 record. Next. So dekat sini kita boleh nampak before cleaning kita nampak total column is 31, total rows is 1194, and then after cleaning total row is 1145. Kita dah filter out 49 yang bawah 2. And then total columns only 3 lah, which is consist of student ID, learning mode dengan CGPA je. So lepas conduct data cleaning, further analyzation boleh dibuat lah. Okay.
So before choosing the right statistics test, we first need to check whether our data follows a normal distribution or not, which is why we conducted a normality test first. If the data is normally distributed, we can use parametric tests like t-test, which is more powerful but requires certain assumptions. But if the data is not normally distributed, we need to use non-parametric tests instead. These tests are more flexible and don't rely on strict assumptions. So next. So for topic 1, our null hypothesis is there is no difference in the distribution of CGPA between online and offline students. And our alternative hypothesis is there is a difference in the distribution of CGPA between online and offline students. So from the result of our test, we refer to Kolmogorov-Smirnov because we use a large data set. Since the p-value, which is big, is less than 0.05, which is 0.01 for our data set, our data is not normally distributed. We refer to p-value 0.05 as benchmark to determine whether the data is normally distributed or not. So next. This is the histogram for offline students. The distribution is more spread out, showing greater variability in CGPA. And the wider spread and visible skew support the non-normal distribution confirmed by the Kolmogorov test. Next. And this is the histogram for online students. The distribution is left skewed, indicating that most online students scored high CGPA clustered near 3.7 to 4 pointer. The range is narrower and the distribution is more concentrated, suggesting more consistent performance among online students. Next. I will pass to Laila.
Okay, so to determine whether there is a difference in academic performance between online and offline students, we used a non-parametric statistical test. Next. So we used the Man-Whitney test to compare the CGPA between online and offline students. Based on the Kolmogorov test, it showed that the non-normal distributions for both groups is less than 0.5, 0.5, so non-parametric metric testing was required. Next. So because of the p-value is less than 0.05, you can see here from the hypothesis test summary, we can say that we reject the H null. Therefore, there is a significant difference in CGPA between online and offline students. Next. So since the z-score is equals to 10.098, it is very high, which shows a strong deviation from the null hypothesis, which means that there is a significant difference in CGPA distributions. Therefore, online students had higher ranks, suggesting a better performance. Next. So now we're going to talk about the frequency graph of the CGPA values between the online and the offline students. So it shows here that more online students scored higher CGPA values, while offline students were more concentrated between the 3.1 and 3.3, which is where the peaks were. And on the right, you can see that most students, which is the online students, clustered at a higher CGPA values, which indicates that there is a strong performance trend in the online learning mode. While on the left side, which is the offline students, we can see that it is more spread out with the peaks around 3.1 until 3.3. This indicates that there are more variations and generally lower CGPA scores. Next. So next we're going to talk about the
overall distributions of the CGPA. So the CGPA distribution is not perfectly symmetric. It leads slightly towards the higher CGPA values with around 3.1 until 3.3. This reinforces that majority of students in these data sets are performing moderately high, especially those in the online mode. Next. And we can see here there is a class imbalance in the data set, which is there is more offline students than online, which online students is roughly around 201 students and the offline, which is around 752. This indicates that the offline group is much larger, nearly 4 times than the online group. Hence, there is a class imbalance in the data sets, which in the data sets, but despite this, the online groups still showed higher CGPA, which strengthens our conclusion that mode of study may influence academic performance. Next.
Okay, now so I can explain about topic 2, social media usage, about are female and male students equally addicted. Next. So social media addiction is becoming more and more common, especially among young adults. In our study, we explore whether male and female students experience the same level of social media addiction. This is important because if there are differences, it could impact their mental health, academic performance, and how they manage their time. Okay, next. To test this, we set two hypotheses. First, our null hypothesis states that there is no difference in social media addiction scores between male and female students. And second, the opposite hypothesis for null, that is alternative hypothesis, states that there is a difference in social media addiction scores between male and female students. Next. Okay, so now we are at data preparation and I will explain about data collection first. So for decisions, we use a public data set from Kaggle, that is student social media addiction, which is contains 13 columns. The dataset was collected through a stupid design which validated tools like the Virgin social media addiction skill and relationship configuration. Participants were recruited via university emails and social media platforms covering various academic levels and countries. Okay, next. So for data cleaning, before analysis, we clean the data to make sure everything was in the right form. For the editors for column, we set the time to numeric and the measure to scale. For the gender column, since it was in the in text format, we recorded it. We recorded it. Male was coded as 1 and female as 2. We named this new variable gender num and set the measure to nominal. This step ensures that the data is ready for statistical testing later. Okay, next.
Okay, thank you. So I will talk about normality test. So what I will cover is about purpose, determine graph shape and skew, test use and hypothesis. So for the first, which is the purpose, it is very important because if the data is not follow normal distribution, we must use non-parametric statistical methods instead of the parametric one. Non-parametric methods do not require normal distribution, which which makes them more appropriate in this context. And then as you can see, we have determined graph shape and skew. This is the graph that we got, which is as for histogram for gender female, which is you can see the right it was right skew. And for the histogram for gender male, we get the mild right skew, which is technically both of them is not normal distribution. So we need to use the non-parametric statistical method. And here is our result. We looking at our normality test result. We use the Kolmogorov-Smirnov test to determine whether the daily usage hours for both female and male student follow a normal distribution. And we chose the Kolmogorov-Smirnov test instead of Shapiro-Wilk because our sample size is greater than 50 for both groups, and Shapiro-Wilk is normally recommended for small sample. And we set our significant level at 0.05 for female student. The p-value for Kolmogorov-Smirnov test is less than 0.001, which is lower than our significant levels. Therefore, we can conclude that we reject the null hypothesis, meaning the daily usage hours are not normally distributed. It's the same for the male student. We can see that the p-value for Kolmogorov-Smirnov is also less than 0.001, which is lower than 0.05, our significant level that we set. Therefore, we reject the null hypothesis for the male group as well, implying their daily usage hours are not normally distributed.
Because the data set is not normally distributed, we opted to use man-Whitney U test where we compare to independent groups when the dependent variable is not normally distributed, which is gender and average daily usage hours. So how do we do the man-Whitney test? Simple. First, we go to analyze non-parametric test and independent sample. Then for test fail, we add average daily usage hours, and for groups, we add gender. Next. Then in setting, customize test, man with EU, and then run the test. Next. On the output, it will show the overview of the test. So firstly, we have the gender count bar chart where it shows the count of females and males that is being tested. And for this case, it is for females 314, for males it is 319, which are equally sized, which supports a fair comparison in the men with EU test. Next, we have the distribution chart. So on the distribution chart, it shows the continuous field information for average daily usage hours for every student, and based on tests that we've been done, approximately bell shaped and a little bit skewed to the right. The mean is 4.9 hours, which indicates on average students spend about 5 hours per day on social media. And then we have the independent distribution chart. It shows the frequency distribution of average daily usage hours for both genders. And as you can see, female students have a slightly higher mean rank, which is 326.04, than male students, 308 and 10. Although the female students have a slightly higher mean rank, um, there's not much difference in terms of the frequency. Next. So this is the final output, the hypothesis test summary. And as you can see, the significant value that we got is 0.217, which is which we make the decision to retain the null hypothesis, and there is not enough significant evidence to conclude that average daily social media usage differs between male and female students. So for conclusion, I pass it to Arisha.
In conclusion, our study found that students who studied online generally scored higher CGPAs than those who attended face-to-face classes. This means the mode of learning, whether online or offline, can actually affect academic performance. On the other hand, when we look at daily social media usage, there was no big difference between male and female students. Both genders showed similar patterns of usage, so we can say that social media addiction levels are not strongly affected by gender. Overall, these findings highlight how learning modes can impact academic performance, while gender does not appear to influence social media addiction levels. Next. And these are references that we refer to while completing this assignment. That's all from us, and thank you for listening.
Thank you.
Thank you.